is our general equation for quadratic equation. But you know, most of those times we used to equate it to 0. For you to find the root of x, you put all your equation to 0. That's where you get the root of x. Then here we are dealing with graphical method. You know, when you want to draw a graph, you need x and y axis. So at this point, we'll start considering y in some cases. Let me say this is x and y axis. So here we are being told to find p. What does this table mean? This table is trying to say that at the point where if the values of x in this equation is equal to minus 2, then y will be minus 4. If the values of x equals to minus 1, y will be 1. So all you need to just choose one of the value here and put it in this equation and use it to find for p. Here, you can choose anyone, but here if you choose this 0, most likely you're not getting p. No why? Let me say I choose 0. I'll have something like y equal to p 0 squared plus 2 0. That's times plus 4 equal to 0. At the end of the day, this 0 will cancel out. You have something like, okay, y is 4. At the point where x is 0, y is 4. So you can replace this y here by 4. So you have something like 4 is equal to 4. So you see that you have already taken out the p you are looking for. That's why this is not a good option to choose. So let me choose at the point where x is minus 1. I'll have something like, at the point where x is minus 1, I put y is what? 1. So I'll replace this y by 1. I'll have something like 1 is equal to p raised to power minus 1, p multiplied by minus 1 squared plus 2 multiplied by 1 minus 1. Why am I not putting this minus? This is minus 1. This is minus 1, please, plus 4. So I'll have 1 is equal to minus 1 squared is what? 1. So I'll have p here plus minus 1 times 2 is minus 2 plus 4. So I will now have 1 is equal to p minus 2 plus 4. I'll have 1 is equal to minus 2 plus 4. You have p plus 2. So it's not like p plus 2 is equal to 1. When 2 crosses equation, you have p is equal to 1 minus 2. P is equal to minus 1. This is the first answer we are looking for. You can confirm it from here. In their own case, they use this first one, minus 2. So anyone you use, you still get the answer. But remember, we didn't use 0 because 0 cancels out the 2. So let's go to the second question they asked. They said, copy and paste the table. Sorry, copy and complete the table, not copy and paste the table. So what they're trying to tell us is to find the values of these remaining ones. So what you're going to do now, since you found your p to be minus 1, you now know that the equation now, you replace this equation you have here, y equal to p x squared plus 2x plus 4. Let's assume, let's divide this into 2, because I want us to be seeing everything that we are doing. So in that case, we already know that p is minus 1. So you now this equation will now become y equal to minus x squared. That's minus 1 times x squared. That's minus x squared plus 2x plus 4. This is the real equation we'll finally have. So for us to complete this equation, this table, we'll now put the values of x and find the corresponding values of y. For in this case, when x is 1, at x equal to 1, we'll now have y equal to minus 1 squared plus 2 1 plus 4. So y will be equal to minus 1 plus 2 plus 4, which should give us minus 1 plus 2 is 1 plus 4. So y is equal to 5. Let's confirm. We are getting y is equal to 5. So we do for the second one, at y is at point when y is 2, we have this same equation. We replace it again. Y is equal to, at point where x is 2, you have something like minus s squared plus 2x plus 4. So this is what we are solving for. This is the equation we are now using to look for it. So at the point when x is 2, we have y is equal to minus 2 squared plus 2 into 2 plus 4. So y will be equal to minus 4, because 2 squared is 4, plus 2 times 2, 4 plus 4. So minus 4 plus 4 plus 4, y will be equal to 4. So we can see we got the same 4. So this is what we'll be doing for the remaining ones. You know, at x, okay, I don't put at x equal to 2 here. So at x equal to 3, using this same equation, y equal to minus 3 squared plus 2 times 3 plus 4. So y equal to minus 9 plus 6 plus 4. Minus 9 plus 6 is minus 3. Minus 3 plus 4 is 1. Y is equal to 1. We can see that we got the same one. So at point x equals to 4, x equal to 4. So using this same equation, y is now minus 4 squared plus 2 times 4 plus 4, which is equal to minus 16 plus 2 times 4, 8 plus 4. So minus 16 plus 8, that's minus 8. Minus 8 plus 4, that's minus 4, which is what we got. So we'll solve for A, I will solve for B. Now let's go to C. C says, using a scale of 2 cm to represent 1 unit on both axes, draw the graph of the relation this for that. Now, what do you mean by a scale of 2 cm? Now, 2 cm simply means one. This is a graph. I don't know if you can see this. Let me zoom it further. So I've zoomed it. They say we should use a scale of 2 cm. 2 cm means one of these boxes, according to this graph, because you know this is how do I put it, a graph pasted on a textbook. So if you bring a real graph, it's 2 cm. So they said using a scale of 2 cm to represent 1 unit. 1 unit means, like the way we have, this is origin, which is 0. This is negative. Okay, let me go up. This is 0. This is 1, 2, 3. So that's 1 unit. So for every 2 cm or every 2 cm, you need it to represent 1 unit. They said we should draw a graph of. This is the graph we are told to draw of this p plus x 4. Let me explain this thing. Whenever you have this inequality and you have something like this is from minus 2 less than or equal to, that's x is between, that's x is less than or, like minus 2 is less than or equal to x, and x is less than or equal to 4. But the fact that you see that equal to sign, it means that you are including minus 2 and 4. Had it been this, let me explain this thing. You have something like minus 2x. Because this sign is there, it means that this minus 2 and 4 are included. But if you have, had it been they draw it like this, no, this one will treat it when we go on to inequalities. It means that this and this are not there. But if you have something like this, it means you are including this, but you're not including. So just note that anytime you see that or equal to sign, means that you are including the boundaries. So that's said. So we are being told to draw the graph of this equation. Remember, this is the equation, but we already know p, so we'll replace it by minus 1. But meanwhile, whatever we need to draw this graph, we've already gotten it in the table we completed here, this table. So indirectly, they are just telling us to express this table in this graph. So what we are going to do is simple. We are just going to, at point where x is minus 2, what is y? So this is where x is minus 2. Y is minus 4. That's the first cross you are seeing. The second one, at point where x is minus 1, what is y? This is where x is minus 1. Y is 1. At point where x is 0, this is where x is 0. Y is 4. That's why you're seeing this cross sign. At point where x is 1, this is where x is 1. Y is 5. See the 5 here. At point where x is 2, this is x2, y is 4. When x is 3, this is x being 3 here, y is 1, this is it. Where x is 4, y is minus 1, so this is x being 4 and y is minus 1. So after you already mark all these points, you will now carefully draw a curve that will take on the points. When we start doing our own I want to first explain what we do our own. So this is now the graph of this equation here. So I have to use the one they've done to explain this. So let's go to the next question. Let me zoom out. So the next question says, I put everything in the book. The next question says, we've already done this graph, right? Now we are in D. Use your graph to obtain the roots of the equation. This. Remember, this equation is the same thing as this equation here. They are still using this first thing they wrote out here, but since we found P, we already know that this is the same thing as this here. So when they say find the roots of this equation, remember what when you're looking for the roots, remember what I said when I was explaining this thing here? That the root only occurs at the point where what? At the point where y is 0. So where is y 0? This is where y is 0. So whatever that is the value of x at those points are the roots of your equation. So whatever that is value of your x at those points are the roots of your equation. So at this point, y is something like, if you check from here to here, you have 1. Now, let me zoom out and I'll explain something. Now zoomed in. Remember we said 2 cm represents 1 unit. So if from here to here represent 1 unit, it means that this small box will represent what? Because it's 5 in number, it will be 1 over 5. That's 0.2 units. So the roots of my equation will be, if I check it very well, so the roots of my equation will be, normally we already know that from here to here is 1. But if you notice, this line cross after the first division. And remember what let me show it. Remember what I showed you, that since we are using 2 cm for 1 unit, you understand? So, but this 2 cm, which is from here to here, is divided into 5. So to get the value of that one division, it will be 1 over 5, which is 0.2. So now, for the first root at this side, we have here to here is minus 1. If you go forward, just only the first division, so it will be 1 plus 0.2, which is what? 1.2. That is the first value of x. That's 1 over 5, that's 0.2. This is the first value of x. Then let's go to the other side. We already know from here to here is 3. Now this line passes through the first division. When I mean division, these lines, these blue lines here, it passes through the first one, which is 0.2. So the second one will be 3 plus 0.2, which is the same as 3.2. So these are the two values of x at the like the question says, use your graph to obtain the roots of the equation. So the roots means at the point where the equation is 0. These are the two values we get. Let's confirm it for what they got. This is C. So let me zoom out again. So let's look for the solution that they got. This is C. And when they solve for it, they got, I think the mistake I made, I forgot that when I was solving for this side is negative side of x, while this is the positive sign. So I forgot to put my negative sign because they had minus 1.2 and 3.2. This side is positive, so this is the same thing I got, 1.2 and 3, but just I forgot the negative sign. So that solves for question D number 1. Then the second one, the equation of the line of the symmetry of the curve. What do they mean by symmetry? Symmetry is the point. Symmetry is something that, let me say you have something like this. Let me say you have to, let me say you take it into 2, divide it equally. Symmetry is the fact that what happened this side is same thing that happened this side. That's symmetry. So at what point is this equation symmetrical? It's obviously the center of this curve here, because if you look, the same value, the same value. So at what point is this center? If you take this, there is a line here. I don't know if you can see it. There is a line here. Let me zoom in so you can see the line. So you see the symmetrical line. You can see this small dotted line that went down. They kind of shifted it a little bit from the where it's supposed to pass, so you can see, but if they put it inside this real line where it is, you might miss it out. So that is a line of the symmetry, and you are being told to find the equation of this line that went straight down like this. So let's zoom out. So I've been told to find the equation of this line. So whenever you have a straight line passing through x, maybe parallel, let me say this one is passing parallel to the y-axis, or you have another one passing parallel to the x-axis. We all know that our general equation of a straight line is y equal to mx plus c. But that's for where you can, this is the gradient of the equation, this is x, this is the constant, this is y. But in this case where you have parallel line from y, or maybe another case of parallel y from x, the equation changes to x equal to a or y equal to a, depending on where it's parallel to. If it is parallel to y, it will be x equals to a, but if it's parallel to x, it will be y equal to a. A is just where the line crosses the x-axis. So in this case, this straight line crosses x-axis at the point 1. So the equation of the symmetrical line is simply x equal to 1. So let's check. This is dii, x equal to y. So this is all about the first example in solving quadratic equation using the graphical method. Even though we did other things like looking for the line of symmetry and looking for that, some cases they will ask you what is the solution to x at point y equal to 2. In that case, this is y equal to 2. You can now check the value of x here and value of x here. These are the two values. But normally, how does this relate to what we are doing before? The roots of the equation at that point, that's where it relates, where we got this 1 point, minus 1.2 and 3.2. If you want to confirm that what we are doing is correct, take this equation, use any formula. Okay, I think factorization method might, I don't know if it can work. Okay, this one is a rational number. Yeah, factorization method can still work. Solve it with any formula and check if you are getting this same minus 1.2 and 3.2. So let's do that. This is no longer graphical method. We're just trying to confirm that this is correct. So let's do that. Let me say I have y equal to, this is our equation, minus x squared plus 2x plus 4. The root of the equation is at the point where y is 0, right? I have 0 equal to minus x squared plus 2x plus 4. I'll prefer to do what? I'll prefer to multiply everything by minus so that this place will give me a positive answer. I have x squared minus 2x minus 4 equal to 0. Remember how we do our factorization method? You simply look for number that when you add it, you get this. When you multiply, you get it. But I think factorization method might stress me a little bit. Let me use the formula method where I have x equal to minus b plus or minus b squared minus 4ac all over 2a. Where is my b? My b is minus 2 and my c is minus 4. My a is 1. So I'm going to write it out. A 1, b minus 2, c minus 4. So let me plug it inside this equation. X is equal to minus 2 plus or minus minus 2 all squared minus 4 times a times c all over 2a. So I'll have minus minus is plus. I'll have 2 plus or minus 2 square is 4. This minus 4 times 1 is minus 4. Minus 4 times 1 is minus 4 times minus 4 again. I have plus 16 all divided by 2. So it will be 2 plus or minus this plus this 20 root 20 all divided by 2. So your x will now be 2 plus root 20 over 2, or x is 2 minus root 20 all over 2. So when you punch your calculator, this is what you will get. It can make a mistake saying that this can be solved with factorization method. I think I failed. I told you not all quadratic equation is convenient with factorization method, and I gave the rules that you achieve if you want to go through that method. It is this b square minus 4ac that you will target. If it's not giving you a real square like a rational root or 0, just know the factorization method will not work. It will be more complex. So this is what we got for the first root and second root. And mind you, I made a mistake. Here is negative from my calculator. I forgot. I always forget this negative sign. So if you check it with what we got from the graph, the first one is 1.2. You see that even if this is in 1 decimal place, so if you change this to 1 decimal place, if you change this to 1 decimal place, it's the same because this is not up to 5, so it will give you 1.2. If you change this second one to 1 decimal place, it's the same. This is not up to 5, it's still the same. So this graphical method, by doing this that I did here, I'm just trying to prove to you that we're not just doing graph or doing graph, say that we're also getting the real solution. So in the next class, I'm going to pick an exercise which we are going to solve together to reinforce our understanding on what we did in this class. Thank you, and see you in the next class.